Hello everybody, in this video I'll be adding EIGRP to this dynamic multipoint VPN, which is a phase 2 VPN. I'm be starting with the branch routers. First I'll show you what IP addresses we have. I have a few loopback addresses that are all beginning with 172.16, and we have loopback 0, which is 1.1.1.1, and you have the tunnel IP, which is 10.0.0.1. The WAN IP, which is not showing here, let me drag it up a bit. Gigabit 00 is 200.100.50.6. That WAN IP you usually do not want to add to your EIGRP autonomous system. So you go router EIGRP autonomous system 1. Helps if you spell it correctly. And the first network I'm going to add is this loopback, which could represent one of your LAN networks. I'm going to add 172.16, which should get loopback 1, 2, 3, 4, 5, 6 and 7 participating. Because 172.16 is a class B network, we do not need to use a wildcard mask of 255.255.0.0. That will be the assumed mask because 172.16 is class B. And then we can put network 10.0.0.0 like that. Again, this is a class A, so the assumed mask is 255.0.0.0, so no need to add anything there. That will get that all to participate in EIGRP autonomous system 1. On branch 2, do a show the interface brief, see what interfaces we need to participate. Start the EIGRP routing process for autonomous system 1, and again I spelled it wrong. So we'll put in the loopback, wildcard mask of all zeros because we want exactly that address to be advertised, or say we want only that address to be allowed to participate, and then add in the tunnel, and the tunnel address of 10.0.0.2 is encompassed by this network address of 10.0.0.0, and if we don't put a wildcard mask, it's because 10 is a class A, it's going to assume a class A mask, which is 0.255.255.255. In this case, that's what we want, so we do not need to add the wildcard mask. And now I will configure the hub. So in the hub, we go router EIGRP 1. We go network 3.3.3.3, the wildcard mask of 0.0.0.0, that's a few too many, and then network 10.0.0.0, and our neighbors come up. Now this is not the end of it, but I would like to show you what are the consequences if you only do it this far before showing you the last few steps. So if we do a show IP route here, we have this 1.1.1 IP, which we've learned via 10.0.0.1. That's on BR1, that is correct. We should have a 222, which we've learned by BR2, that's correct. Can we ping them? So I go here, ping 1.1.1.1, this is from the hub, and that works fine. Ping 2.2.2.2, that works fine. Okay, let's check the hubs. Let's start with, let's check the spokes, starting with BR1. So show IP route. We have learnt, okay, let's do a show IP route EIGRP just to show the EIGRP routes. And we've learned a single one, 3.3.3.3, and where is that? That's on the hub. I'll show you quickly. Show IP interface brief, and there we can see this loopback 333. So that's all we are seeing from BR1 side. Just do it again. Show IP route EIGRP. So that's what we're seeing on BR1, and let's check on BR2. Show IP route EIGRP, and again we're just seeing the loopback advertised by the hub. So the reason for this is EIGRP has the split horizon rule, which says that, for example, the hub, any route that it learns via this interface, it cannot advertise that same route back out the same interface. So the hub is learning the networks of BR1 via the tunnel interface, and it cannot share those networks back out the same tunnel interface to BR2. Again, it also learns the networks from BR2 via tunnel 1, and because of the split horizon rule, it cannot advertise those same networks out of the same tunnel interface to BR1. So we need to disable split horizon on the tunnel interface. So I go into the hub, we go into our tunnel interface, which is tunnel 1, and we say no IP split horizon for EIGRP 1. Okay, and it resyncs our EIGRP neighborships. So we start with BR1 again. Let's do that command, show IP route EIGRP, and we now have two routes. We have a route to the hub, and we have a route for the loopback on BR2, which is correct. But we notice a second problem now, and that is the next hop for 2.2.2.2, which should be 10.0.0.2, is actually the hop of the hub, which is 10.0.0.254. So I'll show you how to fix that in a second, but let's see, can we ping BR2? So we can go ping 2.2.2.2, and we can do a trace route to 2.2.2.2. As you see, the first hop is 10.0.0.254, so the first hop is going via the hub. We don't want that, we'll fix that just now. And let's have a look at BR2, show IP route EIGRP routes, and here we are learning the routes from BR1 172.16.1.0, 2.0, and the main one we wanted to see was 1.1.1. But notice all these routes, the next hop is the hop of the hub, which is 10.0.0.254. Now, if you think about it, this makes sense. The hub learned the route from BR1, and it's advertised the route to us at BR2, and it's made itself the next hop. That's how EIGRP normally works. But in this case, we want it to work slightly differently, so we need to use this no next hop self command. So we are still in interface tunnel 1, and we say no IP next hop self for EIGRP 1. So what this router is saying is, when it gets a route, for example, when the hub gets a route from BR1, that next hop is going to be, let me get this straight, 10.0.0.1, and the hub must hand that route over to BR2 without making itself the next hop. So the next hop is going to stay 10.0.0.1 and not be changed to 10.0.0.254, which is the address of the hub. So we put that in it like that. Just going to quickly save it, and let's check again. We start with BR1. Now let me scroll up here to where it was before. Previously there is your address 2.2.2.2, which was the address on BR2. There you can see the next hop is via 10.0.0.254, that's the hub. We now want it to go directly to BR2, so we can do a show IP route. Just want to see the EIGRP route, so we type EIGRP at the end. And we can see to get to 2.2.2.2, the next hop is 10.0.0.254. Now I'm going to do a trace So watch what happens if we do a trace route to 2.2.2.2. It goes straight there, it doesn't go via the hub. In some cases the very first hop can go via the hub, and then after that you will see that it goes direct, and in this case it went direct the first time. We can try the same here. We can first show you the route. So all previous routes were going via 10.254. Here we do show IP route EIGRP. All routes are now going via 10.0.0.1 because we put that command no IP next hop self on the hub. And here we can start by doing a trace route, and we may be lucky and one of the first packets could go via the hub. So 172.16.5.1. okay, it didn't work like that, but in some cases I have seen it do that. So ping 1.1.1, and we can do a trace to 1.1.1, and that's working directly. Anyway, that is how you set up EIGRP on a dynamic multi-point VPN. Thank you very much for watching.